Inscribed angles. For this first example, we need to find A, B, C, and D. For the first one, to find A, the opposite angles of a quadrilateral that's inscribed in a circle are supplementary, so A plus 108 is equal to 180. So subtract the 108. And A is equal to 72. So you have A. And then we can find B in a similar way. Opposite angles are going to be supplementary, so B plus 92 is equal to 180. Subtract the 92. And B is equal to 88 degrees. So now we have A and B, and so we should be able to find C and D using that information. When I look at C, I have this angle right here, which is the angle 108, and that's going to equal half of the inscribed arc, which is right here, the inscribed arc. So it's going to be half of the C plus the 114. So I'm solving. You can solve in a couple ways. If you multiply by 2, then you get 216 equals C plus 114. And then you can subtract 114 away. And you're left with 102. So 102 is what C equals. And the last one you can find by looking at a different inscribed angle. So we're going to look at this angle right here. So B is going to equal half of the intercepted arc, which is C plus D. But we've already found C to be 102. And we've already found B to be 88. So then we just solve for D. Multiply by 2. And 176 equals 102 plus D. Subtract the 102. And D is equal to 74. For this next example, to find A, that is the measure of this arc, A, 1/2 of A is going to be the inscribed angle, which is 39. So multiply by 2, and A equals 78. All right, then I want to find B. B is right here, which is an inscribed angle that is inscribed inside of a semicircle. I know that because it's going through the center of the circle. So that means B is 90 degrees because that is a semicircle. And the last one is C. I want to find C, which is this angle here. C is going to be half of the intercepted arc of this, but that intercepted arc is 180 minus the 50, because all the way around is 180. So if I subtract off the 50 there, that would be 130 for the intercepted arc there. So half of 130 is 65. So C is equal to 65. For this next example, we have A being this angle right here, and then B being the big arc. So I'm going to start actually by finding b, because I know b plus 144 has to equal the entire circle, which is 360 degrees. So b is going to equal 360 minus the 144. So that means b equals 216. Then I can quickly find a, because a is going to be half of the intercepted arc of b. So a equals 1/2 of 216. Half of 216 is 108. And for this last example, this one might be a little bit trickier. I'm actually going to start out by finding d, because d is this intercepted arc that is connected with this entire 180. So I know that if 180 is going to equal 110 plus the d, so subtract the 110, and d will equal 70. Now that I have d, I should be able to find a, because a is the inscribed angle. So a is equal 1/2 of d. A equals 1/2 of 70. Half of 70 is 35. So a equals 35 degrees. The next one, I'm going to find b. I should be able to find b, because b and a are complementary, because that is a 90-degree angle. 90 equals b plus a, and we already know a to be 35, so 90 equals b plus 35. Subtract the 35 over, and b is equal to 55. So now I have a, b, and d. Now I'm going to find c. I'm going to find c by finding this intercepted arc by taking 180 minus 76 to get this intercepted arc. 180 minus 76 is 104. So c is going to be half of 104. Half of 104 is 52. C equals 52 degrees. Now, the last angle I want to find is angle E, which is easy because E is just the inscribed angle to the intercepted arc of 76. So E equals 1/2 of 76. Half of 76 is 38. So E is 38. So in recap, A is 35, B is 55, C is 52, D is 70, and E is 38. That's it for your examples of inscribed angles. You should now be able to complete the worksheet and be prepared for your quiz.